Yeah, so we have talked about how forces affect. One is that forces make them move. So if there is a force being applied on something, it makes it move. There's an acceleration produced because of it, according to second law of motion, and things start to move in a linear fashion. It is also possible that things turn, and in that case, they can follow a circular path or an arc, and that follows the circular motion. And the reason that happens is because velocity that they have is perpendicular to the acceleration that they have. So there's acceleration towards the center, but the velocity is perpendicular to that. And in that case, what happens is that now the thing is going to move in arc. The third kind of system that happens is that if something is fixed from one point and you still apply a force on that, then that thing will suddenly start to turn. And that is called moment of force. And we talked about it. And the effect of how much that is produced on or how it affects stuff depends on where the force is being applied, like how far is it from the pivot that you have, and also the force that you're applying. And it depends on one crucial factor, that that force should be perpendicular to the distance or displacement from the pivot. So that was the turning effect. Then the third effect that force can have on stuff is deformation, which is what we're going to study today. Deformation. How do things get affected when force changes their shape? So for example, when things don't move, instead they mold into different shapes. So deformation is that their original shapes are affected and they're no longer in that shape. And a common way of looking at that, obviously, one is that if you apply a force on this, and let's suppose there's a wall here, it applies a force on this, this thing may compress. That is possible, that it may compress by a certain distance. It is also possible that if, let's suppose, this thing is fixed from 2 points and apply a force in the middle, this might break. So it is possible that it might break into 2 pieces. We won't talk about things breaking because that is something we don't study in O levels. We will talk about what happens when things move. That's one. And what if you were to change the way that shape was? So deformation. And the second small topic that we will talk about is momentum. All right. So momentum. So let's start with momentum first. Momentum simply says that what exactly is momentum? It's hard to describe what momentum is. We will say that momentum is a quality of motion. All right. So momentum is a way to describe motion. So quality of motion. What exactly is this? It is, the formula is the definition. So P, which is usually used for momentum, this triangle means that this is not only the formula, but also the definition. So P is mv. What this is telling me is that the momentum P is product of mass and velocity. That's what momentum is. And velocity, as you know, is vector. Momentum is also vector. So momentum is quality of motion and momentum is product of mass and velocity. So what exactly is it? It's how, one way to think of what momentum is the impact of something moving. Like if that thing were to hit something else, how much impact would it have? So high momentum stuff has higher impact and lower momentum stuff has lower impact. In fact, this is so important, the idea of momentum, that all laws of motion can be explained through momentum. In fact, that was how Newton originally got to the idea of laws of motion. So momentum is simply the idea that if you have the kind of motion that you want to describe depends on 2 things. One factor is mass and one is velocity. And things that have either of those as high are likely to have a high momentum. So let me give you an example. Let's suppose I have a truck. So there's a food truck and that truck has a large mass. Let's suppose the mass is 2000 kgs. All right. And it is moving really, really slowly, like maybe just 5 meters per second. But a truck coming at a very small speed, even if there's a small car in front of it or a cart, what will it do to it? It will absolutely destroy it. This small car will be like blown away if this were to impact it. It's not a gadi, it's a cart, okay? Just a small shopping cart. Now, another thing that may be really, really small, like a bullet, mass maybe what? Maybe 10 grams, 0.10 grams, let's suppose 0.1 kg, 100 grams. 100 grams is a lot, okay? So 100-gram bullet, but moving at a speed of 8,000 meters per second. The impact that this thing has, maybe there's a wall in there, the impact that it has on that wall is huge. So what's common in both of them is that they both have high momentum. The truck, even though it's moving at very slow speeds, because of its high mass, its impact or its momentum is really, really high. And the bullet, even though it has a very small mass, but that small mass is no problem because it's moving at a very high speed. And with that speed, if it goes and hits into something, the impact will also be huge because both of them have high momentum. So momentum is something that is inherent to anything that moves. All right. And when things collide, and collision is where momentum shows what it really means. When things collide, momentum is transferred. All right, so momentum is transferred from one thing to another, which is why things that cannot withstand that much momentum, they get destroyed. Okay, so this truck, if it were going to hit a cart and the cart wasn't able to withstand that momentum or the transfer that happens in there, this cart will actually be broken down into so many pieces. But yeah, we can say that, oh, this is a very sturdy cart. Then it is possible. Then when the truck comes and hits it, the cart starts to move at much higher speeds than what it was initially at. All right. So the collisions are where momentum really shows what it means. So momentum is a conserved quantity. That is another important idea. Momentum is conserved. What exactly does that mean? You know about conservation, right? We conserve forests. So conserving a forest, what does that mean? You can unmute yourself and answer. All right, so you're saying it can't be destroyed. It is preserved. Yeah, that's what a conserved forest is. We try to make sure that it remains the way it is. All right, we do go one step forward and we start to make sure that it grows and all that, but conservation simply means we preserve things, we try to safeguard things against any outside influence. That's what momentum means over here. Momentum cannot be, so all the things that are conserved in nature, there are many things like energy is conserved, charge is conserved, mass is conserved. Like in most cases, mass is, there are cases where mass is not conserved, but mostly mass is conserved. So these things, they're conserved. What it means is the idea that can't be destroyed and can't be created. So neither destroyed nor created. That's what these things are. You cannot bring a momentum out of nowhere, nothing. And you cannot just completely bring it to zero without having it transferred to something else. Okay. So those are that is what these things are. Momentum is conserved. What it means is that you cannot, momentum is always coming from somewhere else. So if something has this 2000 kg momentum, mass multiplied with 10,000 newtons, or sorry, kg meter per second as its momentum, that 2000 kg meter per second momentum is coming from something else that had some momentum that it transferred to. So for example, in this case, it's the energy of the fuel in there that's causing the engine to move, and that's why it's moving and all that. So there is momentum that is being transferred to the truck because of the effect of the engine. Similarly, when this bullet is fired from any pistol, then that pistol has some mechanism in it where a very high or strong force affects this bullet, and that force has some momentum that it transfers to it. In fact, the way momentum is used to describe force was the original second law. So this is the first important idea about momentum. The second important idea of momentum is that what exactly is this? How is it related to force? So Newton said that force is directly proportional to the rate of change of momentum. This delta P by delta T simply means how much you change momentum compared to how much time it takes. And that is what momentum is. How the momentum of something changes tells us what the force is. So what is force? Force changes momentum of stuff. So if you can change momentum of something, that means you're applying force on it. But we said second law was something else. Didn't we say that F equals to ma was the second law? Yeah, that's the the simplistic view of second law. This is what Newton said, and this is equivalent to this. Easier to understand, obviously. So what does this mean? And how does this equate to that? So let me just transfer it. So it is saying that force is rate of change of momentum. How do you change momentum? You take the initial momentum and you subtract the final momentum. So final momentum minus initial momentum, that is the change, right? And you just see, okay, how much time it took to do that. All right, so that is it. Now, what exactly was momentum? Momentum was mass times velocity of final time minus mass times velocity initial divided by time. Now, here's the thing. Mass is conserved, which means mass final or mass initial doesn't make any sense. Mass is mass, right? So I can take mass out. So I can say that mass into final velocity minus mass into initial velocity divided by time. So I can take mass as common, which leaves me with final velocity minus initial velocity. And does this look familiar? Where have we seen this? In fact, we have seen it in another way. V minus u over t. U is the initial velocity, v is the final velocity. Where have we seen this? Acceleration, yes. So this is ma. So that tells me force is mass times acceleration. So sure, that is what force is. And that's how momentum can be translated into acceleration. That momentum, when it is transferred or when it is changed, things get accelerated. And that acceleration comes from force. So we can say that change of momentum, how fast or slow momentum happens, tells us how fast or slow things will accelerate. Okay, so that means that if you want something to accelerate really, really fast, you want to change its momentum really, really fast. You want to change its momentum in very small amount of time, or you want to give it enough time, but you want to change its momentum greatly. Like you want it to go from a small value to a really large value. And that is how things experience force or experience acceleration. Now, you might have experienced this. For example, you know about inertia, right? You know that things resist change in their motion. So why is that? That is because things cannot withstand a large acceleration. Many things can't. And when that happens, inertia stops them from doing it. Why? What exactly is inertia? Inertia is just something, that a natural thing that resists change in motion, which simply means that it resists too fast transfer of momentum. So for example, you're playing football and you suddenly see that, oh, I have to turn or I have to go in a totally different direction. If you try to do that, suddenly you might fall, right? Or you risk having some discomfort in some muscle or something. Why? Because you tried to change your momentum really, really fast. So if you were going in this direction and you suddenly said, oh, I have to go back, then you can't just go like that. You probably will have to either take a turn, which might be like something like this. Going this and this is really hard to do, right? And that is because your body resists a very high change in momentum. Q. Let's suppose you were moving in this direction. Let's suppose a player weighs 60 kg and their speed at which they're running towards this direction upwards is 12 meters per second. All right, so they're running in this direction. And suddenly they're like, oh, the ball went the other way. I need to go back. And suddenly that person wants to move in the opposite direction at 14 meters per second. So how much do they want their momentum to change in that small amount of time? Let's see. So upwards, their momentum is m into v, which is 60 times 12, which is 12 times 6 is, I don't know, 720. Yep. So 720 kg meter per second. That is what their momentum is upwards. And downwards, what they want to do is they want to move in speeds 60 times 14, and 14 times 6 is, can anybody guess what that is? I don't remember. 84? Yeah, 840. So how much do they want their momentum to change? The change in momentum that they want is they had 720 upwards minus 840 downwards. But because it's downwards, it's going to be negative. It's the opposite direction. So they actually want their momentum to change by this. Whoa. That is a really large change in momentum. And sure, if they try to do that, and if they've succeeded in doing that, depending on how fast they do it, you can do this change in momentum in maybe 30 seconds. Then it's fine. You can withstand it easily. But try to do that in 1 second, you might end up breaking or pulling some muscles. Because that is a really large change in momentum. Kitni large change? It's like something coming at 1 meter per second, but weighing 1560 kg hitting you. That's how much impact your body might feel. Or a 1 kg thing hitting at 1560 meter per second. That is 5 times the speed of sound. Huge change, right? So body will not withstand it, which is why we have a built-in natural process that we resist change in it. And so we probably have to take a longer detour just to give us more time so that the impact that the body feels is lesser. क्यों? जब आप 1560 पर सेकेंड चेंज करने की कोशिश करोगे तो आपको फोर्स मिलेगी 1560 न्यूटन्स. That is a really high force to experience. But give it 30 seconds or 30 बहुत ज़्यादा है. Give it 10 seconds just. So it is 156 newtons, which is still bearable. So that longer detour that you take, it actually saves your life when you're playing football. So that is the change in momentum. Let me show you a video that I saw in which they totally disregarded it. They were like, momentum kya cheez hoti hai? Let me show you. I will have to look for that video. So Hollywood, in fact, even Bollywood, they really don't understand momentum. So I have a really bad quality video on that. Agar aap collisions karte ho. So for example, I have a ball here. That ball is rolling like this. And there's another stationary ball. It's also just stationary, right? So what happens here? So let's suppose this has a mass of 1 kg and it's moving with a speed of 1 meter per second. And this also has a mass of 1 kg, but it is moving at 0 meter per second. It's stationary. So now this ball comes in and hits it. What will happen? So the idea here is that momentum is conserved. Momentum doesn't change. So momentum before equals the momentum after the collision. Okay. So let's calculate what's the momentum before the collision. So it is the mv of the first ball plus mv of the second ball, right? Let me call it u, just to show that it is initial velocity. Now I want to see how fast they both go. Let's suppose they both go together after the collision. So they stick together and they just go. All right. So after the collision, what is the mass of this big thing? 2 kgs. What is its speed? Let's figure it out. So after the collision, their mass is 2 kg, and that is 2 times m, and the velocity is unknown. So let me plug in the value. So 1 times 1 plus 1 times 0 equals 2 times v. So it turns out this is going to be 2 over 2v. Sorry, not 2, 1 over 2v. Yeah. So 1 equals 2v, v is equal to half. So now these things will both slow down because they're both moving. You have increased the mass, you have doubled the mass, the speed will half. And that is how you play snooker. You transfer momentum to one white ball and you transfer that momentum to the other, all the balls that it's going to hit. And you want to control how much momentum you transfer to a certain ball, depending on obviously the rotation of the ball, the eccentricity, the angle, all of those things play a role. And so you want to make sure कि momentum exactly जितना आप transfer करना चाहते हैं वो आप करें, and it goes also in the direction that you want it to go. Because momentum is transferred. Why do things bounce back when you hit them? So I have, let's suppose you're playing squash, right? So if you play squash, then you will see that that ball, if you keep on hitting, it gets hotter. Why is that? Abhi us pe jaunga. But the reason is, or even the wall, because wall बहुत बड़ी होती है और वो अच्छे material से बनाई होती है. But usually, if you keep on hitting one thing बार बार, तो वो दूसरी चीज gets hotter as well. It gets warmer at least. And the reason for that is that it is constantly transferring its momentum to that other thing. Now, obviously, that thing cannot be broken or moved. Wall तो उठ के कहीं जा नहीं सकती. तो क्या होता है? वो ball वापस bounce करके आती है आपके पास. So let's suppose I have this ball here, and this ball suddenly goes, it's going to come back. Why does it come back? Because momentum अगर transfer नहीं होगा तो किसको मिलेगा? इसी ball को वापस मिलेगा. So let's suppose this is a small ball of maybe 200 grams, 0.2 grams, so kgs, and this is moving at high speed of 10 meter per second. और ये वापस आती है. So obviously उसका mass change नहीं हुआ. So हाँ, कितनी speed से वापस आएगी? अगर momentum बिल्कुल ही transfer नहीं होता, तो momentum before equals to momentum after. So ये पहले जितना momentum था उतना ही बाद मिलेगा अगर transfer बिल्कुल नहीं हुआ. ठीक है, तो वो बन जाएगा 10 times 0.2, तो 2 kg meter per second उसका momentum है. But what is the change? I'll talk about friction in a bit. What is the change in momentum? पहले momentum 2 kg meter per second था इस direction में, अब 2 kg meter per second है उस direction में. So the change in momentum is 2 minus -2. So it is 4 kg meter per second. So जब वो rebound करके आती है ना, वो बड़ी जोर से लगती है क्योंकि वो जो वापस आ रही है तो उसमें मोमेंटम में काफी ज्यादा चेंज आ गया और वो वही 2 kg per meter per second का मोमेंटम आके ट्रांसफर कर देगी. So when things move, when things hit each other, they actually transfer their momentum, and that momentum then creates a force, and how fast or slow that momentum is transferred changes how the impact of that thing is. You can take any one side as positive, but usually we say right and up to be positive and left and down to be negative. Usually we do that. So अगर आपका दो तीन चीजें हैं, let's suppose there's this ball that is coming in this direction and there's this ball going in this direction, and let's suppose this has a mass of 2 kgs and it has a speed of 5 meter per second, and this has a mass of 10 kgs and it has a speed of 5 meter per second, and they say, all right, after the collision, so this is before the collision, and this is initial velocity, this is initial velocity. They say, okay, after the collision, this goes into this direction and its velocity is 8 meters per second. Find the speed of this thing after the collision. So that's a question. Oh, it's really simple. The ball was moving with the momentum of this much, and it hit the wall and it came back with the same momentum, because ball is something that will not absorb the momentum, let's say. So the change in momentum that this ball is facing is 4 kg meter per second. So how much force, we can also increase it. Let's suppose this all happens and the time for which it is in contact with the wall is 0.3 seconds. That's a large amount of time. So how much impact, 0.2 seconds kar lete hain. How much force is the ball facing or feeling, experiencing when it hits the wall? So force is change in momentum over time. So that is going to be 4 divided by 0.2, which is 40 over 2, which is 20 newtons. Itni zyada force feel hoti hai is ball ko. So that is why when you hit something and it hits a wall, it's not that the wall broke it. It is because that thing could not withstand such a high change in its momentum. उस पे जो force लग रही थी ना, उसने उसको तोड़ा है. It's not the wall. The wall is innocent. Yeah, we are assuming here that momentum isn't transferred to the wall. Yes. Okay. This one, what happens here? So this ball, which is much heavier, 5 times heavier, and it has a pretty high momentum. It's coming and hitting this small ball, which has similar speed. So let's suppose what is the momentum before, and we know that it is equal to momentum after. All right. So momentum before is m into u of the first thing plus m into u of the second thing, And momentum after is m into v of the first thing and m into v of the second thing. Usually we call it mu1 and m1 u1, m2 u2, m1 v1, m2 v2, just for differentiation. Okay, so this becomes 10 times 5 and this is 2 times 5. And this thing is, we don't know what the speed of that thing is, but the mass is 10. So 10 times v, and mass is 2 and it is 8. We are assuming the ball didn't break. So it is exactly 2 kgs afterwards. So now this is going to be 50 plus 10, and this one is going to be 10v plus 16. So now if you subtract it, so this is 60 minus 16 divided by 10, which is the velocity. So the velocity of this bigger ball after it hits it is going to be, what is 60 minus 16? 44, so 4.4 meters per second. So what has happened? The thing, this big ball, it has slowed down from 5 to 4.4 meters per second. But what happened to this ball? It suddenly increased its speed by 3 meters per second. Why? Because the momentum that was transferred to it made it zoom out. Kafi zyada speed. All right. So that is how things collide with each other. And obviously, this is a very simple model where we are assuming that things only go left or right. We are not involving 2 dimensions or even 3 dimensions here. When you play any sport or when you hit stuff or whenever things move or there's an impact, obviously it happens in 3 dimensions. So that usually needs to be evaluated. But the ideas are still the same, that momentum remains conserved. Now, here's the thing. What about energy? Is energy conserved in collisions? So for that, we have to specify what kind of collision it is. We usually say that collision, I don't know how to spell it, collision can be elastic or it can be inelastic. What is elastic collision? Elastic collision is when kinetic energy is conserved. I'm not saying energy is conserved. I'm saying kinetic energy is conserved. And what is inelastic collision? When kinetic energy is not conserved. So what happens? In elastic collisions, things come and hit each other, but their individual kinetic energies may change, but the overall kinetic energy of the whole system does not change. Inelastic collisions are when kinetic energy does change during a collision. And how does kinetic energy change? The energy gets transformed into some other form of energy. And that is why when you hit stuff repeatedly, it starts to get warmer. And that is because the collision is inelastic. The kinetic energy that it has, it is losing that and transferring it to some other form of energy like heat. So any collision where the things get hotter or the temperature changes or sound is produced, those collisions are inelastic collisions. And elastic collisions are when kinetic energy of the things is conserved. So there is no change in the kinetic energy of the overall things. Why is this important? Because it tells us, it allows us to identify what collision is BS. So this is our rule there. We can use this to identify whether something is even realistic or not. So for example, this setup that I gave you, let's see कि ऐसे हो भी सकता है कि नहीं हो सकता, and what kind of collision it is. So let's identify this. Interestingly, kinetic energy is scalar. So what is the kinetic energy before the collision and what is the kinetic energy after the collision? So let's see. This ball, 10 kg one, it had 1 by 2 mv squared. The other one, 1 by 2 mv squared. So this is before the collision, okay? So how much is that? This is 250 over 2. So this is 125. And this one is 25. So that is 150 joules. Overall kinetic energy is 150 joules. What am I saying afterwards? So I'm saying that after the collision, that thing is moving at 1 by 2 mv squared plus 1 by 2 mv squared. So can you figure this out? So this is 5 times 4.4 squared, and this is 64. Can you figure this out? It is 96.8. So this 96.8 and that is 64. So 96.48 plus 64, that is 161. 161 joules. How does that work? So let me illustrate. Can I get charon? If this situation happened, energy is suddenly created. We have suddenly violated law of conservation of energy. Things collided and 11 joules of energy suddenly burst out of nowhere. BS. Nonsensical. Doesn't work, doesn't happen, unrealistic. So clearly, whoever set this thing up is a big liar. Impossible scenario. Why? Because energy can either remain 150 or be less than that, the kinetic energy. हाँ, ये हो सकता है कि 150 में से कुछ energy heat में convert हो जाए, sound में convert हो जाए, or overall things slow down. But this scenario, where this thing is moving at speed of 4.4 after the collision and this is moving at 8 after the collision, impossible. नहीं हो सकती. क्यों नहीं हो सकती? Because final kinetic energy can either be what it was initially or it can be less than that. So this is a very good litmus test of knowing whether a collision can work or can happen or not. Collision can be elastic, in which the overall kinetic energy is the same at what it was afterwards. Or it can be inelastic, where kinetic energy is reduced and some energy is transferred to heat or other form, but it will never cause an increase. And this is why when things bounce down, तो होता क्या है? आपने एक बॉल यहाँ से फेंकी, वैसे आके लगेगी, फिर ऐसे आएगी, फिर ऐसे आएगी, फिर ऐसे आएगी, फिर ऐसे आएगी. क्यों ऐसा होगा? Because जब वो यहाँ पे आ रही है, उसकी कोई mgh है, पोटेंशियल एनर्जी है, कुछ काइनेटिक एनर्जी है. जब वो वापस इधर आएगी, यहाँ पर there is change in momentum happening when it's rebounding, when it's bouncing away. And because the collision is inelastic, there's going to be some loss of kinetic energy. So that is why अगर हम कहें ना कि elastic collision है, तो ये तो हो सकता है कि वो यहाँ से आए और मैक्सिमम इतनी हाइट पे ही वापस चली जाए जितनी हाइट पे पहले थी, लेकिन कभी भी इससे ऊपर नहीं जा सकती. ये नहीं हो सकता कि यहाँ से ऐसे ऊपर जाए. Impossible. And that is what you use when you're designing roller coasters. कि आपने यहाँ ऊपर ले जाके कहाँ से उसको छोड़ना है और वो कितना हाई आपका ट्रैक हो सकता है जिस पे वो जाएगी. And obviously you need to make sure that the journey that it takes is good enough or long enough to change the momentum of people inside in a way that they can sustain that fall. Same thing you use when you use the lifts, when you design lifts. So you are designing a lift for a very tall building like Burj Khalifa or something. You can't just put a magnetic levitation train type lift in there, because जितना भी distance travel करवाना है lift से, लोगों ने उसको experience करना है और लोगों की body एक खास momentum बर्दाश्त कर सकती है, खास change in their kinetic energy and momentum it can sustain. तो आप उसको देख के इसको slow down या fast करते हो. That is what you use whenever you are designing airbags. कि airbag कितने time में आएगा, so that the change in momentum, the force that the person experiences, the time, which is crucial, airbag will increase the time so that you experience less force, so you can sustain that impact. So understanding momentum is critical. There's only one thing where you don't need to understand momentum, and that is if you're the director of Fast and Furious. Otherwise, it's important that you understand this. All right.